Have you ever been stuck in that tangled mess of distributed systems, just wishing there was an easier way for all your services to talk to each other? Well, if that sounds familiar, you're in the right place. Today we're going to pull back the curtain on a technology that aims to fix exactly that. The big question is, what the heck is NATS?
So, here's how we're going to break it all down. First, we'll cover the absolute basics, what NATS actually is and its two core ways of communicating. Then we'll get into the fun stuff, a couple of power-ups that make NATS so incredibly flexible. And to wrap it all up, we'll see how all these simple little pieces can snap together to build something really, really powerful.
You know, at its heart, NATS is all about tackling one of the biggest headaches in modern software, complexity. The whole idea is for it to be this simple, super performant, and flexible connective fabric that just holds your whole system together.
I think the best way to think about NATS is like the central nervous system for all of your applications. It's an open-source messaging system that's built for speed, but its real job is just to simplify how everything communicates. And we're not just talking about a couple of services in one data center. We're talking about a flexible network that can handle huge global challenges, from multi-cloud setups all the way out to the edge.
Okay, so NATS messaging kind of comes in two main flavors. You've got NATS Core, which is all about that super fast, fire and forget style of messaging. Then, for the more complex stuff, there's NATS Jetstream, which adds things like persistence and true streaming. For this explainer, we're going to stick to the absolute foundations, which all live in NATS Core.
All right, let's get to the real heart of NATS. The whole philosophy here is that pretty much any kind of communication you can think of, no matter how complicated it seems, can actually be boiled down to just two super simple patterns. Let's see what they are.
The real magic behind NATS is this beautifully simple idea called subject-based addressing. Instead of your services needing to know about IP addresses or ports, they just talk to each other using plain old text strings, like "Hello, Jeremy." As long as two services agree on that subject string, they can communicate. They don't need to know where the other one is. It could be on the other side of the world. This decoupling is what makes NATS so powerful.
And that simple idea leads us to the two fundamental ways of talking in NATS. First, you have services. This is your classic one-to-one conversation. You ask a question, you get one answer back. Simple. Then you have streams, which is more like a public broadcast. One service makes an announcement, and anyone who's tuned into that channel can hear it. That's it. It really is that straightforward.
So we've got our basic building blocks. But what happens when one of your services starts getting really popular and is just getting hammered with requests? Well, this is where NATS has a brilliant and simple answer for scaling things up.
And that answer is something called queue groups. A queue group basically lets you have multiple services all listening on the very same subject, and then NATS steps in and automatically acts like a traffic cop, balancing the load between them. You get instant scalability and load balancing right out of the box without needing any extra hardware.
And check this out. Here's what that looks like in the real world. You throw 1,000 messages at a queue group with two services in it, and NATS distributes them almost perfectly, 500 to each. It's just built-in, effortless scaling. It's pretty incredible.
Okay, so that's how we scale. Now let's talk about flexibility. This is where another NATS power-up comes into play, and it's called wildcards.
Wildcards are awesome. They let a single service listen to a whole bunch of different subjects at once. So the little asterisk, that matches a single word. If you subscribe to hello dot, you'll get messages for both hello Jeremy and hello world. But the greater than symbol, that one's a real powerhouse. It matches everything that comes after it. If you subscribe to just greater than, you're basically in wiretap mode. You get to see every single message flowing through the entire system. You can imagine how useful that is for monitoring or debugging.
All right, so now we have all the pieces on the board: services, streams, queue groups, and wildcards. Let's see how they all snap together to create a seriously powerful and modern microservice architecture. Okay, let's build a microservice in literally 3 commands. Step 1, we create a flexible service that can respond to any hello request using a wildcard. Step 2, it's getting popular, so we scale it up instantly just by adding a second service to the same queue group. And step 3, we make the whole thing observable with a single command using that wildtop wildcard. And we're done. It's that easy. So think about what we just built in a few seconds. We have a microservice that is completely location transparent. The services have no idea where the others are. It's automatically load balanced, and the entire system is observable with one simple command. This is the whole point of NATS, taking simple ideas and combining them to create really sophisticated, resilient systems.
Honestly, we've barely even scratched the surface of what you can do with NATS. But it leaves you with a really interesting question, right?
If the communication layer of your system was this simple, this powerful, what kind of complex problems could you finally go out and solve? What would you build? Thanks for joining me.